Hello and welcome back to the Swiss AI podcast named This is the Year. In today's episode, together with me is Joao, the AI engineering wizard, and we're covering the new Claude Anthropic model that's been rumored to be released very much soon called Mythos. We also are covering today a little bit of a technical insight from Google. They released a new paper that pretty much just made all the stocks in terms of memory dump, and that would then also lead us to a bit of a finance corner. A quick measurement, what's actually happening in the world of AI investing, is then the last stage of today's podcast. But to you, Joao, how is life? How is Lisbon? I've heard you also almost encountered summer yet. Or how's the vibe there?
The weather is pretty good. I was very happy with the state of things. Got a little bit less happy with the state of things since the paper from Google got a bit of recognition again and the whole market started going upside down. We'll get into that in a minute.
So it's good weather for Portugal and bad weather for the AI investing stock market. If you're completely new to the show, we usually have some sort of a finance corner. And 1 year ago, a little bit, well, basically one of the very first episodes, we were usually talking about all these memory stocks. The reason why they were flying is because of reasoning. And we've seen a huge acceleration of demand for all these Crons and ASCII Hynixes of the world. But in today's video, let's quickly first focus briefly on all these rumors in around Claude Mythos, this new model that's already tanking some cybersecurity stocks before it even was released. What would you say, Joao, are you expecting after Claude Opus 4.6? What is this model? Is it an entirely new category, or is it an Opus 4.7 or 5 like it is rumored?
A few months ago, I would say that it's another gradual step, like another gradual improvement on the current capabilities of LLMs. We have seen some fantastical breakthroughs in the last few months that makes me believe, or allows me to believe, that it is more than just an incremental step. We are at a stage that it's hard and harder to understand the increases in capabilities of these models. I mean, you can look at benchmarks and get an idea through there, but in your day-to-day use, it's harder to notice when a model is significantly smarter because the frontier models are already pretty smart. I don't know if it is, they rumor it to be a whole new tier of model. So in the Claude lineup, we had Haiku as the fastest, and Sonnet, the middle ground, Opus as the most expensive, the most capable, the smartest, and also the hardest to run. But also incredibly famous, and I think pretty much everyone in the coding world is using Opus 4.6 in their setups, even if they're using Cloud Code, Copilots, or any other open.
Yeah, it's pretty much in every stack. I think Cowork, that was like the model that was a bit of this step function change. I think Opus 4.6. Anyway.
So do you think it's a whole new tier of model? Basically, if either model is entirely different or they're running it for an incredible amount of time, like they're doing for compute, they're noticing that the agents, like you've talked about running agents for many, many hours and almost like programmatically at night running them for tasks. And they might think, and they might be picking up on that and say, hey, if people want to run for like 5 or 6 hours, that's going to cost them something different, probably something higher. And we're going to price them in a different tier, like the highly autonomous mode.
It's probably a good segue into what is happening next in the next, I would say, array of models, not only Mythos, but the equivalent from Google and from OpenAI and all the, let's say, open source models around there. Certainly, we probably see more autonomous execution of the agents. Just to wrap that into 2-3 sentences here, the way you would run currently long-running agents is you have to have a very strong harness. So you have to engineer an AI agent harness that is somewhat capable of checking itself. There is a new, I would say, it's not entirely new, but some sort of an ideology. Okay, you probably cannot do it in one go. So probably there is an iteration. You maybe have a checker or some sort of evaluator component. So every time the Opus 4.6 is generating a particular code element, you probably have an evaluation going. And all these components you probably would need, like you would have for a human, right? So if a human works for 12 or 16 hours, if you're in consulting, in finance, or if you're on a bender in coding, you probably also don't do it in one full go. You probably are executing a bit of work. So you're creating a work or business artifact, and then you have some sort of a self-review, self-check after, say, 30, 45, or 60 minutes. And the exact same equivalent will be happening when you actually have long-running AI agents. Mythos might actually be a completely new tier that is simply better harnessed, right? So Opus in itself is just a large language model like you would get from an AWS Bedrock or some other service. And yet the capability release, the way it actually makes it into a Claude Code, into Claude Cowork, or into any other agentic AI system is really the harness. It's the skills around it, and it's the way Anthropic engineered the harness around Opus 4.6. Might be that, yes, Mythos might be kind of a new step function change in terms of the model per se. Let's call it Opus 4.8 or 4.9. But they probably spent a significant amount of time into optimizing the harness around it. That's why they maybe call it Mythos. But the base model is maybe more a step function change of Opus, yet the harness has been engineered a little bit more in terms of the business value creation. Again, working longer, being better embedded into whatever it needs in terms of context, maybe a much larger context window, maybe a lot better practices of compressing the context, maybe better in tool calling and skill utility, all these elements that actually make it viable in the business world. So I see that happening more also that, yes, it's maybe a completely different model category, but not only on the LLM-based intelligence, but also on the functionality in the business world. So that's my best read in that. When do you think Mythos is released? If we look into the future, maybe we are dropping this video on hopefully the very beginning of April, late of March. But when do you think we can expect the Mythos?
I don't think Anthropic is rushing it at all, and I don't think they have a reason to do so. I mean, they're on the bleeding edge right now. I think they're on the number one in a bunch of benchmarks. New models have come out since 4.6 Opus from different major AI providers, and none of them have managed to beat Opus. So if they're doing it purely out of, I wouldn't say fun. There's some massive profit to be taken there, but I'm not seeing it happening in the next couple of weeks. They're gonna let at least the hype that internet is causing to grow and see how the people in the audience are perceiving it, so that they can launch and seize the full PR and branding that comes from it. Because right now they're not in a rush at all. GPT and OpenAI would be. Google is also battling for first step. They're lead in some of the benchmarks, but Anthropic, I think it's very comfortable right now. So I'm not sure how ready the model is, but they're certainly taking their time.
I mean, it's probably a good estimate that you were mentioning. I mean, usually they were following, what was it, like a 6 or 7 month model release cycle. In that particular case now, I do believe, once again, I was asked this question by one of the students I was teaching in my AI class at the uni here in Switzerland, if this is now the end of let's say, scaling, or the model's not getting better, yada, yada, yada. And I think something most people still forget, NVIDIA is shipping next frontier chips in Vera Rubin, but most, if not all of the models that are being currently even fabricated, let alone being in Claude Code or Cowork, they have not been trained on Vera Rubin. They have hardly been trained maybe on Blackwell or the previous iteration of chips by NVIDIA. So if we take all the software improvements, maybe more on that just in the next few seconds on this paper from Google, plus we have the hardware improvements from NVIDIA's new Vera setup, which is a multitude of chips, not only Vera chips, but also we have anything from Grok, the acquisition, not Grok with a K, but Grok with a Q. That is basically a multitude of chips in one huge system, in one rack from NVIDIA. And that in itself, just these two things compounding, better algorithms on training and then on inference, plus better hardware to simply train the model, will ultimately, even if we don't do anything for the next 2 years, yield in a better model than Mythos and than Opus, certainly. So yes, 120% we will see better models very much soon, maybe the next 6 to 12 months, when the release of Vera Rubin was injected into the data centers, and all the labs, Anthropic, OpenAI, Google, and so on and so forth, were then using and leveraging these new chips and these racks, basically these mega super token factories, to be trained the next frontier model. So that's anyway happening in the next few months, but not for Mythos. That will already be for the next large language model that we are seeing early in 2027. That's why I'm an incredible believer. Yes, models are getting better. They're both getting better in terms of harness utility. They're better in skill utility and tool calling, and their base intelligence will just, again, probably keeps climbing many iterations. Every time there's a new model, we have better base intelligence plus better business artifact creation in code and some sort of analysis. And they also can run a little bit longer like they used to. Even that's maybe my last reflection before we talk about the stock market, which I think is a bit of a mispricing, misperception. Because if I observe myself, we're in AI now, maybe you're even longer than me, for the last, let's say, 3.5 years in generative artificial intelligence. I came from doing one request maybe every few minutes or one question every few minutes to literally running simultaneous agents almost 15 hours a day. So even if I observe my own utilization of these large language models and all these multi-agent systems now, it literally probably a million X, because I literally asked one question, I got one question back. That is it. Versus now, all these agents, I'm literally at this very moment when I'm shooting the pod, I have 4 agents running, doing stuff for me in the background, and they are generating an order of magnitude more tokens than I used to just 2-3 years ago. That is why I believe, if we can segue into the stock, let's say, game a little bit, there was this tanking of the stock market in general. Many of the chips players were down, and not only NVIDIA, but we also had one particular domain, and I give you the word back to talk about this, Joao, in regard to the memory stocks. What exactly happened? Why is Micron, SK Hynix, SanDisk, and Sony, and all the other players in this space down significantly? What might have caused this, other than some issues on the war front, essentially?
Academic research, basically. And the academic part is a big part of this, because Google launched one of the papers Google launched, because they do release quite a few. It's been nicknamed TurboQuant. It's about, in a summarized way, a way to run these models, run LLMs with a very reduced memory footprint. So you take, let's say, 80x less memory to run the exact same model, slightly different architecture, and you can run it with the same performance, on even sometimes having performance gains. So having better context recall, having this faster inference, in some cases cheaper inference. This means that you can run or build models that are equivalent to the ones today, but using way, way less memory. So you're thinking, okay, this is a whole brand new technique, came out last week, stocks are down. Well, the paper is out since last year, since March 25. And so no one really took much notice of it outside of super specific academic circles. But now it's being presented in a high profile conference, ICLR 26. People are talking about it. And now that the paper's getting traction outside of academic circles, people are starting to notice. And of course, the AI market is very reactive. And to the site and to the small thought of needing a little bit less memory makes all the memory stocks go down significantly, and like billions of market capital go down. Is this a whole like eureka moment for AI? It's similar to what happened with DeepSeek. I mean, it is remarkable for research, remarkable for AI development. It's not going to change stuff 100%. It's going to make stuff better, possibly have cheaper models. So we might possibly pay a little bit less, not the next couple months, but maybe towards the end of 26, where we have models with this architecture, and we might have models that are more widespread. Again, when you make models cheaper, more people can access them. You can access them for more things, and you can apply them in a more widespread kind of way, which is beneficial, I think, for all. No one wants models to be consuming the amount of power that we'll be using for crypto, or like just burning through energy like crazy. So it's a good thing in general. Bad thing for the stock market, though.
But bad thing for the short-term perception of the stock market. Maybe I can just put in 2 tweets here from Gavin Baker and Bill Ackman. I think these both are a little bit the AI bulls, I would say. They were saying, yes, now might be an interesting opportunity just to look into these stocks once again, because we have forward price earnings ratios that are a little bit more milder than they used to be, let's say, in mid to end 2025. Now, what the paper is really outlining, just to double quick that very briefly without going too much into the technical nuances, it's called TurboQuant Online Vector Quantization with Near Optimal Distortion Rate. What that means, in other words, in order to process information, you would usually use something called vectors in a large language model. Like the ultimate math behind the scenes of any AI that is running on a transformer architecture is ultimately vectors and matrices. So ultimately, you have vector to matrix multiplication. You might have all these sub-elements. And ultimately, the more, let's say, high-dimensional a vector, or let's maybe put it in simple terms, the more the more long the vector really is, the more you can actually even bake context into a particular one vector. And this is pretty interesting. So you can, for example, encode meaning of a word. You can encode, for example, even particular parts of an image into a very long, super high dimensional vector. This is all great and really interesting. Mathematically, it also works. You would then just simply, again, basically multiply this vector with a matrix. The problem is this requires a significant amount of memory just to actually process all this, let's say, vector to matrix multiplication or these very large vectors in itself. And this paper basically suggests a way to compress or to quantize such a, let's say, very long, dense vector, basically. And that's pretty much what this paper suggests. It's not a completely and entirely new mechanism. We've seen data compression for quite a while. It's been around for tens of years, probably. And it just a little bit reimagined how this would actually then apply to large language models, or particularly within LLMs, all these vectors that we can now compress. That is more or less what you were mentioning, Joao, just all the scare, all these memory components. If you ask me, that kind of drills back to my statement before. My usage of it also probably a million X. So I would also be keen to also be aware once they ran all the tests, if that actually has a production impact by, let's say, 20%, 50%, or 100%. If the utility again goes up by an order of magnitude, like where are the net savings? And probably the answer, more likely than not, is we might still need a lot of memory to actually process long-running agents. And if we don't get algorithmic improvements like with vector quantization, like it is explained here in the paper, we probably will actually never land in the world where we can have these long-running agents that are actually being really working highly effectively. If I draw an example, then I give back the word to you, Joao. Just on my own workflows with agents, they're not the fastest workers, right? They need to compress after every 2 to 3, maybe sometimes 5 minutes, they need to compress the conversation. So that's something they need to continuously do. Then maybe they execute a few more things for me. For example, they outreach, they do some sort of code generation. And I would probably say the agent is around 4 times more slow than I am as a human, which I don't care because it can run 15 hours. But ideally, we probably need mechanisms so it actually speeds up. That's what I'm trying to say. So even if memory is getting a little bit compressed, or actually it's getting a little bit of a boost, we might just need an order of magnitude more, and then we're on the same level as we are today. So that's a bit my read into this whole SOC conundrum. But anything else to add, Joao, from your end?
Yeah, and also not to forget that memory is still back ordered to the near to medium future. So even like, and a news story that came out quite recently is Sony, one of the OG suppliers of SD cards. So think photography and like cameras, they're suspending their memory card orders just because the NAND memory that they need to build these SD cards is in such shortage globally. And so if you take like your hobby is photography, if your hobby takes anything related to SD cards, even setting up like small Raspberry Pi computers or whatever you need SD cards for, you are now being outbid by data centers. Data centers are still being built at a super aggressive pace. They still need the components and all the hardware to build them. And all those components, all that hardware is still back ordered. So it hasn't even been produced yet. It's already being bought and sold and planned to being installed in some data center somewhere. So we still need memory. We still need a whole lot of it. We're still figuring out ways to build it faster and cheaper. And so even though the markets react, of course they do, the demand for memory is not going anywhere anytime soon, unless we think of a dramatically new way of building AI. And I don't think that'll happen anytime soon. Or if it does, it'll still need memory.
I mean, 100%. I mean, not that we give any financial advice on this channel, but we shouted out like, the very first days when we saw reasoning on the horizon. But the next frontier might be we need actually a lot more memory that people are aware of. Now, what is next? We have long-running agents equipped with harnesses, equipped with skills that are most of the time consuming an order of magnitude more tokens. So I think the demand is, again, just skyrocketing in this next frontier where we have a one-to-one relationship with a chatbot, or let's say a ChatGPT, a Claude, to now more and more becoming to a one of many, right? So you have one interface, and this is launched multiple agents at the same time. They in itself, they need memory. They need a lot of compute. They're being fed different skills, and they're executing more or less autonomously into different organizations. And you kind of replicate that by the workforce of millions and millions of Europeans and Americans and Australians and everybody in the world. So yes, more likely than not, we will need more chips, more memory. We maybe are in need of faster transmission between the data centers if we're doing decentralized training clusters, for example, that is coming up with maybe silicon photonics. We maybe need to look into more laser-based communication like a Lumentum or something similar that they're providing. And I don't think it's actually going down. It's just going in the other direction. If you're really truly building in the space, like we're trying to share here on this channel, I do feel we are as constrained as we have ever been. Also, if we look into, I can put it on the screen, the Claude status, which is usually not green. This might tell you a little bit of a picture of how compute and maybe also memory constrained Anthropic really is by launching the dispatch function. And everybody is on the phone now dispatching agents. They have Claude Code up in the running. They have Claude Coworker up and running. So of course, they don't have an uptime like you would expect. What's your expectation usually on the uptime, Joao, and how high is Claude fulfilling that requirement?
Usually we measure it as the amount of nines, so 99.99% uptime, so 5 nines, 6 nines, 7 nines. I think Claude, especially some parts of Claude AI, is at 1 9. So it's I think around 98%, maybe 97% if they had some shortage or outage until now. 1 9 is a dramatically low number. I think I have set up servers for my own personal use that even them have like higher hub times. Even like if my power goes down, I still maintain across the year more than 1 9 of uptime. And Claude is struggling with that. I don't think it's the lack of engineering. I don't think it's the lack of skills on their side. They're certainly well staffed. I think it's the lack of hardware. And managing that hardware is incredibly hard, especially when people are flocking to Claude and leaving ChatGPT in record numbers. They have to find this GPU, they have to find this compute and these data centers somehow.
Exactly. I think it's a good point to wrap up the episode as well. So I think the market is trying to signal that there is some sort of under demand and all the things are crashing. And that's probably the end of the AI race. But if you're really a builder in the space and you're actually utilizing the tools heavily, like we maybe, and you as well in the audience do every single day, you can, of course, realize that they're probably heavily resource constrained and they would like to ramp up faster. They would like to yield more product features like an OpenAI would like to and an Anthropic would like to. They were shipping quite a lot of features, Dispatch, Claude Cowork, Claude Code, everything in the last few months. And now they're also, again, shipping this new model that we talked about maybe the next months and maybe even a few weeks, called Mythos. And that in itself will again accelerate the need because most of these larger newer models, they are also more compute and memory hungry than the smaller ones. And all that being said, I think it was a good episode just to wrap up the latest releases on Mythos, the latest releases on TurboQuant by Google, this vector quantization paper that would, again, maybe be the missing building block that we can finally have long-running agents and we don't have to wait forever that they execute certain elements. And then we wrapped it up with a bit of a finance fever check where we believe the market is a little bit misaligned and might actually is due a little bit of a correction / let's say rebound. TBD, no financial advice, as always here on this channel.
Of course not.
But there is certainly 2-3 very famous individuals in the infrastructure investing space, like a Gavin Baker, that is also observing this. And yeah, so that's it for the episode. Thank you, Joao, for joining. I see you in the next almost 50th episode. If you're new to the show here, we shoot these episodes every single week, and the next one will be dropping after Easter. Take care, everybody in the audience. Happy Easter break, and we talk soon. Bye-bye.
Bye-bye. See you.